This will be a video on higher order derivatives, so you can actually find the derivatives many times as you want. So I'll just do a couple examples. So the first derivative on the first example here, I copy the 3, the derivative of x squared, I bring the 2 in front, the exponent decreases by 1. I have 2, the derivative of x, I bring the 1 that you don't see in front, subtract 1 from the power, and the derivative of 1 is 0, so we get 6x plus 2. That's the first derivative. I can take the derivative again, and so I take the derivative of the derivative. Here's the derivative, so I copy the 6, I bring the 1 in front, it's x to the 0, and the derivative of 2 is 0. So now I have the second derivative will be 6. I can find the derivative again. So I'll take the third derivative, which can also be written this way. That's another way to write the third derivative. And I just take derivative of 6, which is a constant, so it's 0. I can do it again. The fourth derivative, which is f parentheses 4. Now if you don't have the parentheses here, it's going to be an exponent and not a derivative. Well, 0 is a constant, so the derivative is 0. So you probably noticed the rest of the way the derivative will remain 0. Okay, this one's a little trickier. I'm going to rewrite this one. That's x to the 1/2 power. So the derivative, I copy the 3, but you learned the derivative of e to the x is itself. So that stays the same. And I bring the 1/2 in front, decrease the power by 1, so I get negative 1/2. And I can do this again. So I take the derivative of the derivative. This stays the same. I bring the negative 1/2 in front and decrease that by 1/2, and I get that. So this simplifies to minus 1/4 x to the negative 3 over 2. I can take the derivative again. I can do this as many times as I want. That doesn't change because e to the x, it's its own derivative. And now I copy the constant, I bring the negative 3/2 in front, decrease the exponent by 1, I get that, and that simplifies to this. I can keep going forever on this, but I'm going to stop here. That's higher order derivatives. Bye.